Alright, so here we are. We're going to go ahead and solve the system of three variables. So just like when there's two variables, what we need to do is try to eliminate one of them. Okay, so I'm going to call this one equation number 1, this 2, and this 3. So if I want to get rid of something, an easy one to get rid of here would be to get rid of my x's. And I'm going to go ahead and take a look at equations 1 and 3. So if I took equation 1 and I subtracted equation 3 from it, that means that I would have x plus 2y plus 2z equals negative 2. And then I'd have minus equation 3, which is x minus 3y plus 2z. And I'll go ahead and distribute that negative in a second. I'll multiply this by negative 1 here. So what I'll really end up with here is x plus 2y plus 2z equals negative 2. And then over here I have negative x plus 3y minus 2z equals to 7. So when I go to combine them together, the x's all cancel out, and I add my y's together to get 5y, and what's really awesome here too is that my z's cancel out, and so I'm just left with 5. So 5y equals 5, so divide by 5, and I get y equals to 1. Okay. So what's really nice about that now is that now if I know that y is equal to 1, I can take that and plug it back into any of my equations, and I will have it in terms of just in terms of x and z, and then that kind of brings us back to what we're used to doing. So I'd like to, if you could go ahead and write a roadmap of some sort to tell me kind of what you're doing here, like where I did the 1 minus 3, that tells me what equations you did here, and then down here I found y equals 1. So what I'm going to do here is I'm going to go ahead and I'm going to plug y equals 1 into, and I don't want to use 1 and 3 again because I want to involve 2 in this thing too, because it's the intersection of all 3 of these lines here. So I'm going to plug y equals 1 into equation 2 and equation 1, we'll say. Okay, so when I do that, I have equation 2 becomes 2x plus minus y, and I put that in here, plus 3z equals to negative 6. So when I have equation 2 here, I'm going to go ahead and add 1 to both sides so I can get that over here. So now I have 2x plus 3z equals to negative 5. Okay? And that's pretty nice because now if I do the same thing, maybe I'll call this equation 4, just so I can keep track of things here. But if I plug, this was equation 2 right here, if I go ahead and plug this into plug 1 into y equals 1 into equation 1 here, I would have equation 1 x plus 2y, so x plus 2 times 1 and plus 2z equals to negative 2. Okay, so now that I have that, I'm going to go ahead and simplify here, and I have x plus 2 plus 2z equals to negative 2, so I can subtract 2 from both sides. Okay, so I have x plus 2z equals negative 4. Okay, so I'm going to call that equation 5. So now if you take a look, equations 4 and 5 are in terms of the same two variables. Okay, so you got to think, what can I do to combine those together? Well, you can do substitution here, but I'm going to go ahead and stick with elimination because that's what I was doing before. So I'm going to draw a little arrow up here so I know that my work continued up here. But here I'm going to go ahead and I'm going to say, I want to get my x's to cancel, probably the easiest thing, so I'm going to take equation 4 and do minus 2 times equation 5. Okay? So if I take a look, now I have 2x plus 3z equals to negative 5. And then equation 5, I'm going to go ahead and multiply the negative 2 through it. So I'm going to save myself a little time to distribute that negative 2. So it becomes negative 2x minus 4z equals to 8. Okay, and now when I combine these things, the x's cancel out. I'm left with negative z equals to 3. So I divide by negative 1 here. And I end up with z equals to negative 3. Okay, so right now I've got y and I have z. So if I want to find x, all I have to do is plug in both y equals 1 and z equals to negative 3 into any of the 3 original equations. So I'm going to say here, plug z equals negative 3 and y equals 1 into equation 1. Okay, so when I do that, equation 1 was what was it here? So it's x plus 2 times 1 plus 2 times negative 3 equals negative 2. So I start to take a look at this and combine like terms and everything. Of 2 minus 6, that's going to be negative 4, so this would be x minus 4 equals negative 2. And I can go ahead and add 4 to both sides, and I get x equals 2. Okay, so I have x equals 2, y equals 1, and z equals negative 3. So I'll have the coordinate triple here instead of a pair of 2, positive 1, and negative 3. And those would be my intersection. Okay, I hope this helps.